Hello and welcome everybody to this class. Today we are going to discuss triangles. Triangles is a very important topic. It is very useful in the higher examinations also. I would like to tell you all about the triangles. I would like to cover the properties of all triangles. Now let us see first what is a triangle. Triangle means a closed figure with three sides. We are starting with the basics. Okay. Three sides. These are three sides. Let us name them. Let us name the vertices A, B, C. It is a closed figure with three sides. A is a vertex, B is a vertex, C is a vertex. These 3 points are called vertices. Each one is a vertex. Okay. Now the side opposite to capital A, that is opposite to the vertex A, is referred as small a. Likewise, the side opposite to the vertex C is taken as small c. The side opposite to B, the vertex B, is considered as small b. This is the notation we follow. Okay. Now, in each triangle, if you see, sum of these three internal angles, these three are known as internal angles. Sum of these internal angles, sum of these internal angles is 180 degrees. Remember, how do we write the angles here? Angle A. Angle at A is written as angle A plus angle B plus angle C. Sum of these three, A plus B plus C angles, is 180 degrees. This is a very important fundamental in triangles. Now let us see the other things about triangle and the kinds of triangles that we have. So all these things now we shall discuss. Okay. First, you remember what is a triangle and how do we refer the sides, the notation and all that. And basic property about the sum of angles is 180 degrees. And more importantly, another one I would like to tell you, some useful properties of this triangle. Now let us see. If you want to see the three sides to form a triangle, basic necessity is sum of any two sides, sum of any two sides must be greater than the third side. Greater than the third side. Let us discuss this property. Sum of any two sides. If you take any two sides, measures of the sides, for example, if A is equal to 5 centimeters, B is equal to 6 centimeters, C is equal to 7 centimeters. Now let us see, can we form a triangle with these measurements? A is equal to 5 centimeters, B is equal to 6 centimeters and C is equal to 7 centimeters. And to check that, sum of any two sides you take, 5, 6, A plus B, 5 plus 6. Easily you can consider A plus B, 5, 6. What is 5, 6? 11, which is greater than the third side, 7. So, okay. That means need not take only these two. Any two you can take. B plus C, for example. B plus C, if you take, what is B? 6 plus 7. That is equal to 13, which is greater than the third side, 5. Likewise, A plus C, if you consider, what is A plus C? A is equal to 5 and C is equal to 7, whose sum is equal to 12, which is greater than the middle side, that is B, 6 centimeters. So you can form a triangle with these measurements. This is what you need to understand. Let us take some negative example to understand this rule better. For example, A is equal to 8 centimeters, B is equal to 2 centimeters, and C is equal to 5 centimeters. If you check the same property, B plus C, consider. B plus C. What is B plus C? B is equal to 2 centimeters plus C is equal to 5 centimeters. And sum of these 7 centimeters. What about the third side A, which is less than 8 centimeters? Third side A. That means it should be greater than the third side, but here it is just less than 8 centimeters. In fact, you can write this one as not greater than 8 centimeters. So that means the rule states must be greater than, but here it's not greater than. So you cannot have a triangle with these measures. Normally in the examinations, you will be asked to say which set of measurements make a triangle. Okay. In that case, you have to check the rule like this. Take the sum of any two sides and see whether it is greater than the third side or not. In all the three cases, if it is true, you can say that set of measurements will form a triangle. This is one important property you must know. Now, let us see the same. Now we have taken the sum of two sides. Instead of that, there is another rule. Difference of two sides. Difference of any two sides should be less than the third side. Less than the third side. Now let us take example and discuss. Remember, in the earlier property, what we have seen is the sum of any two sides must be greater than the third side. But in this case, the difference of any two sides. Let us take a set of measurements. A is equal to 5 centimeters, B is equal to 6 centimeters, and C is equal to 7 centimeters. The same measurements we have taken, which we have taken in the previous example. Now let us work out this one. Difference of two sides, A and B. You can write difference like this. Difference is 6 minus 5. It's not the subtraction symbol. It is just a difference. So 6 minus 5, that is equal to 1, which is which is less than the third side 7. So this is proved. With A difference B we have seen. Now B difference C, if you see, what is B difference C? B difference means 7 minus 6, that is equal to 7 minus 6, which is equal to 1 centimeter, which is less than 5 centimeters, the third side. Likewise, C difference A, if you consider 7 minus 5, that is equal to 2 centimeters, which is less than the third side B, that is 6 centimeters. So in this example, we have taken the difference, not minus here. We have taken the difference. That means the positive sign we take. Whichever is greater, we write first, and then smaller one we write second. A difference B, B difference C, likewise C difference A. The difference has come less than the third side, which is a clear one. So with this set of measurements, you can form a triangle. Okay. Now let us take another example with the same property. A is equal to 9 centimeters, B is equal to 2 centimeters, C is equal to 6 centimeters. In this example, let us take the difference between the two sides, A and B. What is A? 9. B is 2. 9 minus 2 is 7. Is it less than 6? Check. This is not less than 6. This is not less than 6. In fact, greater than 6. That means the set of measurements given here cannot form a triangle. So this is what you must know. Okay. So we have seen the two important properties along with the basic property, sum of three angles. Now let us discuss the kinds of triangles. The kinds of triangles. Okay. Now classification of triangles or kinds of triangles, if you call this one kinds of triangles. We divide triangles by their side, lengths of side, and depending on the angles. So based on the sides, triangles are divided into three types. One, equilateral triangle. Two, isosceles triangle. Three, scalene triangle. See here, we have classified triangles into three types on the basis of their lengths. We discuss the properties of these three kinds in detail. Another one is based on the angles. Based on the angles, we decide them as acute angled triangle, acute angled triangle, two, obtuse angled triangle, obtuse angled triangle, acute, obtuse, and lastly right angled triangle, you can call it right angled triangle or right angled triangle. Now we discuss the properties of each of these in detail. Okay. Now let us take equilateral triangle. Let us discuss the properties of all these in detail. First, let us take equilateral triangle. Take equilateral triangle. What is an equilateral triangle? A triangle in which all three sides are equal. A, B, C. A, B, C can be called as an equilateral triangle if three sides measure the same. For example, we write like, that means equal means we write the symbol is equal to symbol like that. That means the symbol with this symbol, whichever sides are there, are equal. For example, if this is A, this is A, this is A, that means AB is equal to BC is equal to CA. The side AB is in fact all are equal to A. This is A, this is A, this is A. All are equal to A. That means all three sides are equal. Okay. This triangle is called equilateral triangle. For example, if this is 5 centimeters, it is 5 centimeters, it is 5 centimeters. Likewise, it is. All three sides measure same. Then it is called equilateral triangle. Okay. Now, in this equilateral triangle, we find something, some interesting facts to be noted. Okay. What are the facts relating to the equilateral triangle? In equilateral triangle, if you see, each internal angle is equal to 60 degrees. First one, you can say all sides are equal. All sides measure, all sides are equal. That's what we say in the beginning. Second one, each angle is equal to 60 degrees. Each angle is equal to 60 degrees. And we have to understand at another important factor, and I'll cover that one in the later videos, but for the fact you understand this, normally we write median. If you draw a line from the vertex to the opposite side, it passes to the midpoint and it lies perpendicular to the base. It divides the opposite side into equal parts. It divides the angle here also equally. It bisects. Okay, angle bisector. So one line if you draw, if you join the vertex to the midpoint of the opposite side, that becomes altitude, angle bisector, perpendicular bisector, median. So all four are the same line. So if you draw a line here from this side to that and this side that, all intersect at a place, this point becomes, all four centers are the same point. That's what you must know. So median, perpendicular bisector, median, perpendicular bisector, angle bisector, median, perpendicular bisector, angle bisector. Likewise, what is the other one? Perpendicular bisector, angle bisector, altitude are the same line. This point needs to be discussed. This point needs to be discussed in detail because there are four centers. There are four centers in each triangle, and all these four centers become the same point in equilateral triangle. You know what are the 4 points, 4 centers here? If medians bisect, that is 3 medians pass through the same point, that point is known as centroid. Okay, that means centroid Likewise, and coming to this perpendicular bisectors, three bisectors pass through the same point. The concurrent point of the perpendicular bisectors is known as a circumcenter. That is known as circumcenter. And coming to the angle bisectors, three angle bisectors meet at the same point, and the point is known as incenter. And altitudes are also concurrent lines, and these concurrent lines meet a point, or they pass through one point, that is called orthocenter. Remember, so there are four centers to be understood, and if possible, I will give you another video on these clearly. Medians pass through one point, and that point is called centroid. Perpendicular bisectors pass through one point, that is called circumcenter. And altitudes pass through one point, that is called orthocenter. Angle bisectors pass through one point, that is called incenter. These four centers are the same point here. Remember that. All 4 points, all 4 centers remain at the same point in equilateral triangle. This is what you have to understand and remember very, very long, because this point proves very crucial in doing some important problems. Okay, this is all about equilateral triangle. And if you still want to know what is the area of an equilateral triangle, I'll give you that one also. Area. Okay. And if you go to the area part, you need to have some longer proofs to determine, but I'll give you the results of that, because proofs, if you consider doing all that proof, it takes a lot of time. Instead of that, I'll give you the area of this equilateral triangle. Area of the equilateral triangle. Area of the equilateral triangle is given by the formula root 3 by 4 into a square. Root 3 by 4 into a square. Okay, this is simple as that. And I have to make a special video on how to find the area of an equilateral, because that takes itself half an hour time to do this one. Okay, but remember the area formula, which is very important for you, root 3 by 4 a square. Okay. These are the things you have to understand about the equilateral triangle. And now let us see what is the second type of the triangle. The second one, as I said, is isosceles. What is an isosceles triangle? Isosceles. Remember, if you take a triangle like this, A, B, C, two of the sides are equal. If two sides are equal, then the triangle is known as isosceles. So here, which sides are equal? AB is equal to AC. Two sides are, of course, in the diagram for convenience, I have written like that. Instead of that, AB, BC can also be equal. But in this example, a particular example, I have shown you like this, AB equal to AC. Okay. If this is to be AB is equal to AC, then this triangle is known as isosceles. A very simple rule, very simple fact you have to consider. And what more to be discussed? If AB is equal to AC, we understand that it is an isosceles triangle. Means, if two of the sides of a triangle are equal, then it is isosceles triangle. Okay, well, And what properties that you can bring out of this? See, these angles B and C, okay, are the angles opposite to the equal sides. AB and AC are known as equal sides. What is the angle opposite to AB? Angle opposite to AB is C. What is the angle opposite to AC? That is equal to B. Try to follow this. Angles, these two angles, which are opposite to the equal sides. Angles which are opposite to. Angle opposite to AB is C. Angle opposite to AC is B. Okay. These two angles are equal. That's what you should know. Angles opposite to equal side. The word you have to understand. AC, if these two sides are equal, since these two are equal, the angle opposite to AC is B. The angle opposite to AB is C. These two must be equal. This is another property you have to get. Okay. So these two things you must notice. And in the earlier rule, in the case of equilateral triangle, as I said, the concurrent lines, the concurrent points, centroid, orthocenter, circumcenter, incenter. In the equilateral triangle, all lie at the same place, but here they lie on the same line, not exactly at the same point, and which will be understood in the later course. Okay, so these are the things we understand about the isosceles triangle. And coming to the area of this one, we normally have the same formula, like half into base into height can be used to find the area of this one, because no other specifications are said about this one. Because if there is any right angle or any such conditions are mentioned, we think about the other formula. But for the time being, you understand the area of this triangle can be found with the help of the same formula, half into base into height, which is the common formula to find the area of the triangle. Okay. And coming to the other kind of the triangle, that is scalene triangle. Scalene triangle. What is a scalene triangle? Scalene triangle means three sides measure differently. A, B, C. In the picture itself, it appears that three sides are unequal. For example, if this is 5, this is 8, this is 7. Measure, if you measure, as an example I have shown you like this, we understand that three are different sides. This is like this is like this, and this is unlike marking. Like marking means all are equal, but here unlike marking. Three sides measure differently. In this case, we understand that this is a scalene triangle. Very important. AB is not equal to BC is not equal to AC. We can write like this because no side is equal. No two sides are equal. Or you can understand that no two sides are equal. This is a very, very nice way of giving statement. No two sides are equal. Learn this word, no two sides. No two are equal. No two are equal. Such is the way we define scalene triangle. Scalene triangle means all sides measure differently. No two sides are equal. And is the same case with the angles also. No two angles are equal. No two angles are equal, because if two angles are equal, it becomes isosceles. Remember that. So no two angles are equal. Likewise, we understand. Coming to the area, if there is no condition specified, we apply the same formula, half into base into height, to find the area of this triangle. Remember, there is another formula for finding the area of any triangle. If the sides are given, we come to that later, square root of s into s minus a into s minus b into s minus c. That is another one that is commonly applicable, because I say that formula after this classification. So area we can use half into base into height, that is what. And in mensuration we get a formula to find the area of this triangle using a formula called Heron's formula, square root of s into s minus a into s minus b into s minus c. This is applicable to all kinds of triangles. Remember, delta stands for area of the triangle. Remember, it is applicable to all kinds of triangle, but you must know what is A, what is B, what is C, and what is S. S is called semi-perimeter, and it is understood and it is obtained by A plus B plus C by 2. Sum of the sides by 2. A is one side, as I said, A, and B is this one, C is this one. A plus B plus C, sum of these three sides by 2 gives you the value of S. S is called semi-perimeter. You know, perimeter means sum of the three sides. Semi means half of that. That's why by 2 is there. Remember, A plus B plus C gives you semi-perimeter of that. And by 2, if you divide that one by 2, you get half. Then half is called semi. Okay, semi-perimeter. And A, you know, what is A? What is A? A means opposite side of the vertex A. So, B is like that, C is like that. So, use this formula, you can find the area of any triangle when the measures of the sides are given. So, this is what we discuss regarding the classification of triangles on the basis of their sides. Okay. Now, let us discuss the kinds of triangles on the basis of angles. Okay. Here you see acute angled triangle. What is an acute angled triangle? If each angle is less than 90 degrees, remember, each angle is less than 90 degrees. Angle A, angle B, angle C. So, angle A must be less than 90 degrees. Angle B must be less than 90 degrees. Angle C must be less than 90 degrees. Each angle is less than 90 degrees. Then it is called acute angled triangle. That's all about this one. Because, and area, as I told you, to find the area, very simple. As in the earlier cases, as I said, 1 by or half into BH is the same formula to find the area. And other issues, if you consider sum of the angles, because we know sum of angles in each triangle is 90 degrees, that is also applicable to this one. Not much to think. And coming to the in center, all lie in the interior of the acute angle triangle. That is what you must know. The orthocenter lies in the interior, circumcenter lies in the interior, in-center lies in the interior, orthocenter, circumcenter, centroid, and all four centers lie in the interior of the, because this is what you must know, interior or exterior, that's all, interior of the triangle. Okay, that one you should, all four centers I am referring, you know what are four centers, many times I said, four centers remain inside, remain in the interior of the triangle. This point, some of you get confused sometimes. That's why I'm clearly telling you all four centers means, remember, centroid, orthocenter, circumcenter and incenter. Okay, all lie in the interior of the acute angled triangle. And that is all about this one. And next one, obtuse angled triangle. Obtuse angled triangle. Obtuse angle. You know what is an acute? As I said, acute angle is 90 degrees, less than 90 degrees. Obtuse angle is greater than 90 degrees and less than 180 degrees. First, that is the definition is also very important. In the earlier case, I didn't tell you. Acute angle means less than 90 degrees. Acute angle is less than 90 degrees and greater than 0 degrees, of course. And obtuse angle means angle which is greater than 90 degrees and less than 180 degrees. That is called obtuse angle. Obtuse angle. Angle means obtuse angle. Obtuse angle is obtuse angle. It's greater than 90 degrees, or otherwise you would write 90 degrees less than obtuse angle and greater than 90 degrees. 180 degrees. 180 degrees is, this obtuse angle is less than 180 degrees. Okay. 90 degrees is less than. We can call it like that. It lies between 90 and 180. I gave the symbol, wrong symbol here. This is 90 degrees less than obtuse angle less than 180 degrees. 90 degrees less than, that means obtuse angle lies between 90 degrees and 180 degrees. 90 and 180. You can write like this also. This is called open interval. We come to that in the higher classes. But remember, for this 90 and 180. Okay. Between 90 and 180 obtuse angle lies. If a triangle contains one obtuse angle, for example, if you see A, B, C, we are in the obtuse angle triangle. Here you see this angle is greater than 90 degrees. Clearly we understand that it is greater than 90 degrees according to the appearance of the picture. So angle B is greater than 90 degrees. So this triangle is understood as obtuse angle triangle. Sometimes if one angle and the sum of the other two angles are definitely less than 90 degrees. A plus C becomes less than 90 degrees with no doubt. And coming to the area, area is found in the same way as I told you in the earlier sums. Half into base into height, or otherwise Heron's formula is there. With that also you can find when sides are given. So this is about obtuse angle. Coming to the centers. As you know, this is greater than 90 degrees. Always there is a chance for some centers to lie outside. Because you cannot draw. For example, if this line is like that, and if you want to write an altitude here, altitude comes in the exterior. So definitely orthocenter lies outside. Likewise, perpendicular bisector, if you take that also, if you draw perpendicular bisector like that, and that also goes somewhere outside. So likewise it happens with this, and nobody asks you particularly about this one, but remember, centers lie outside. And coming to the point, right angle triangle, which is very, very important. Right angled triangle, very, 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 very important kind. You must know there are so many properties about this one. So many in the sense, I will not cover everything of the right angle triangle in this video. I'll come with another video about this one. It lies like this. One angle is 90 degrees. One angle is 90 degrees. and sum of the remaining two angles is 90 degrees. This one and this one. A, B, C. Right angled triangle 90 degrees. And sum of these two must be equal to 90 degrees because this is 90. All three should be equal to 180 degrees. Hence it is, since it is 90, the remaining two must be equal to, the sum of remaining two must be equal to 90 degrees. So this is what about right angle triangle. The height of this triangle becomes this one. Okay. AB becomes a height in this case because altitude coincides with the side itself. And that's why orthocenter lies at the angle containing the right angle. Here you see orthocenter lies at the side at the vertex containing right angle. Right angle, wherever right angle is there itself the orthocenter lies. And depending on the side's length, we discuss the circumcenter and other that. There may be a chance that the two sides can be equal. In such a case, this becomes a right-angled isosceles triangle. That also we get in the different examples. If two sides are equal like this, and this is a right-angled triangle, that means AB and BC are equal. AB and BC are equal, and this is a right-angled triangle. Then you call it as a right-angled isosceles triangle. Right-angled isosceles. Right-angled isosceles triangle. Right-angled isosceles triangle. And there are some other properties to be discussed about this one. Right angle. This is what about a right-angled triangle. Right-angled triangle. Okay. This is right-angled isosceles triangle. And for this one area, if you consider, one side becomes height, the other side becomes base. So apply the same formula, half into base into height. Base of this one, if base of this one is small a and height is c, and this is given by half AC like this, you can find its area. And let us now see what is the area of right-angled isosceles triangle. Okay. How is a right-angled isosceles triangle and their sides? Now let us see. Right-angled isosceles triangle. If you see right-angled isosceles triangle, if you take, so the many things can be discussed, but for the time being, let us take right-angled isosceles triangle and finish this. Right-angled triangle is like this and two sides are equal, and if each one is A, B, C, because since these two are equal, we write as A. And its area, if you understand, its area is half into base into height, as I said, half into base is the same side A and height is A. That is what you get, A square by 2. A square by 2 gives the area of the right-angled isosceles triangle. Okay. In this case, our circumcenter lies at the midpoint of the diagonal. Midpoint of the diagonal. Midpoint of the hypotenuse. This is the hypotenuse. Opposite to the right angle, the side opposite to right angle is called hypotenuse. Hypotenuse. Right angled hypotenuse. Opposite to right angle, the side lies is known as hypotenuse. There is a property, very famous theorem about right angle triangle, that is Pythagoras theorem, and that can be discussed in the other videos. And for the time being, you understand the area of a right angle triangle as right angle isosceles triangle as a square by 2. And if you use the Pythagoras theorem and get the length of the hypotenuse, for this case, I tell you, hypotenuse is equal to square root of, according to the Pythagoras theorem, what Pythagoras theorem states, sum of the square on the hypotenuse is equal to sum of the squares on the other two sides. That is equal to length of the hypotenuse is equal to square root of a square plus a square, that is 2a square, that is equal to, you get to it as root 2a. I give you the formula to find, and how to derive this formula we discuss in other videos. The video becomes lengthier. Just understand the area of right angle isosceles triangle and hypotenuse of the right angle isosceles triangle. So these are the kinds of triangles we discussed. Okay. And there are so many things to be discussed, and so many problems can be worked out on these triangles. Using the properties of these triangles, we solve many problems in competitive exams. Okay, in the next video, I will bring you some problems related to triangles which can be solved using these valuable properties. Thank you for watching this video. If you like this, share it and subscribe to my channel. Thank you.